POSIX for threads. But from our syllabus point of view, we are going to do what is known as PT threads. So I have some video lectures for which I have already shared with the class on this POSIX threads. There are 2 video lectures that I'll play today. Just hold on. Get this. Are you able to see the thing?
In today's video, I want to take a look at a short introduction on how to use threads under Linux on in C. First things first.
Are you able to hear? Students, are you able to hear?
Sir. Yes, sir.
Yes,
Yes,
sir.
sir.
Okay.
First, we need to include our header file. So we're going to include pthread.h. And one more thing that you have to do extra besides just including the file itself is a link option, right? And this link option goes to the command that compiles your source code. So my command is found inside tasks.json, and I have added it here, -pthread. So if you're using VS Code, you just have to add it here. Otherwise, you just have to add it wherever as an argument to the GCC.
Sir, can you play in full screen, sir?
That's very important. Otherwise, nothing is going to work regarding threads. All right. Now that we have that, we can start creating threads. Now, the basis of creating a thread is that when you create a thread, it executes a function, whatever function you create. So we're going to start by creating a simple routine that does something very generic, and we're going to try to execute it using the thread creation. So what we'll do here is just create a function. I'm going to call it just routine, but it can be anything else. And I'm going to give it any arguments. What I'm going to do is just add here a printf saying test from threads, let's say, \n. Okay. Okay, now that we have the function, to start creating the threads, we first have to define a sort of place where basically the API can store some information about the thread. And that place is a variable, of course, but the type is pthread_t, and I'm going to call it t1 from thread1. And you'll see exactly where this is going to be used. Now, to initialize the thread, we just call the pthread_create function. And this guy looks a bit more complicated than other basic functions, but trust me, it's not that scary. The first parameter is the pointer to this t1 variable that we have created here. So it's just simply you pass in a reference to it. That's very simple. Next up is the attributes. So these attributes are regarding customization of certain things that you can do with threads. But what you can do, since it's a pointer, you can just pass null, and it's going to set it up itself with default attributes. So you don't have to deal with that. Next up is the actual function that is going to execute when it creates the thread. We're going to just pass in routine, but to pass in a function as a parameter, we have to pass in, of course, a function pointer. So I'm going to get the reference to that routine. And lastly is the argument that is going to be passed to the routine. Since we don't have any arguments here, I'm just going to pass in null, and it's not going to pass anything else. Okay, one last thing we have to do, similar to how we do with processes, is we have to wait for that process, or for the thread in this case, to finish its execution. How do we do that? Because usually you don't want the process to finish its execution and then the thread to be in the middle of executing something. You know, that's going to just terminate the process altogether. So what we have to do is call another function that says pthread join, and this is basically the wait but for threads. And we just pass in here the actual struct. So this t1 that holds the information for our thread that we have created here, and then we can pass in some pointer that gets the result from that thread. But since we don't return anything, we don't do anything special with the thread, we don't care about it, we're just going to pass in null. And that's really all there is to creating a thread. Just create a struct, a variable where you can store some information about the thread, call the pthread create, call the pthread join, and you're basically done. Now, if you try to run this, you'll notice we're going to see tests from threads printed on the screen. So that's very nice, but how do I know that this is in parallel? Well, we can try to create more threads. So if I want to create another thread, what I have to do is declare another pthread_t type variable. So t2 here, call pthread create again. So I'm going to change this to t2, and I'm going to call or execute the same function. So we're just still going to call the same function, but it's going to be from a different thread. And of course, wait until it's finished executing. So t2 as well in here. Now, if I try to execute this, I'm going to see this printed on the screen twice, of course. But how do I know, again, that this is in parallel, right? We are dealing with threads. We're trying to execute things in parallel here, but it's kind of difficult to figure it out. Well, what we can do is print two messages inside the function here. I can say printf this message, and I can wait a while. I'm going to call sleep and wait, let's say 3 seconds, and I'm going to print, let's say, ending thread, right? And if this function would be executing twice, one after the other, you would expect that first you'd see tests from threads on the console here, and then you'd see ending thread, and then again tests from threads and ending thread. But if you try to execute it, you instead see test from threads twice, and then ending thread twice here. Although I did forget a \n, so let me just fix that and execute again. You'll notice that we get that twice. So that means that both threads executed that printf statement. It got to the sleep of 3 seconds, so both threads kind of paused their execution for 3 seconds, and then it printed again ending thread at the same time, more or less. Now, one important thing before going is to error check Oreo function calls, because here I'm assuming that I can create these threads, but in actuality, in a Linux environment, you can actually suppress people from creating threads, or simply just not have enough resources to create those threads. So there could be some errors occurring behind the scenes. Therefore, we're going to check here. This pthread create, for example, returns an int, and this int is either 0 or something different that represents an error number. So what we can do here is to just add an if statement that says if whatever returned pthread create is not 0, that means that there was an error that occurred. I'm just going to return an error code myself, so return something different than 0, and do the same for all the pthread related functions. I'm going to return 2 here. Let's say these numbers, these return values don't hold any meaning right now, but we can give them some meaning if we want to. And now if I try to launch this, it's going to be the same, of course, but at the very least we know that our code is a bit more safer than before. All right, that's about it for today. If you do have any questions, do leave them down in the comments below or on our Discord server. You will see the source code up on the CodeVault website. I'm going to leave a link to this specific lesson on the website to it. And otherwise, take care. Bye.
So this is another video on multi-threading.
What's up, everybody? My name is Moss Norman, and in today's video, I'm going to walk you through how to write a multi-threaded program in C. I thought it was time to do a follow-up video from my previous video on multi-threading, introducing you to the concept. It's now time to see a concrete example of multithreading. And in order to write our multithreaded C program, we're going to make use of a library called Pthreads. Pthreads is short for POSIX threads. The Pthreads library offers an interface through which you can create, update, and destroy threads in a program. And as we write our code, I'll explain the basic functions that you call from the Pthreads library. So with that, if you haven't already, grab a coffee and let's get coding. Okay, so I have my editor opened. I'm using Atom to make this program, but you can use whatever editor you prefer. I've created a new file and I've called it mt-example.c, and this is going to be our multi-threaded program. And the first thing that we need to add in the program is we need to link the necessary libraries. So the first one that we're going to add is standard input output. Then we're going to link the standard library. We're also going to link the library to interface with the POSIX API, and then we'll also link the Pthread library. Okay, so the Pthread library is the library that provides an interface for interacting, creating, and destroying new Pthreads. So the next thing that we're going to do is we're going to create a main function. And inside of that main function, we're going to declare a new variable called TID0, and it's of data type pthread_t. And that data type is something that's provided by the Pthreads interface, and it's to uniquely identify a thread. So this is actually just going to be a large integer, basically. And it's going to uniquely identify the thread that we're about to create. After we've declared this variable, we can then call the pthread create function. And the pthread create function is what's actually going to initialize a new thread. And it takes several arguments. And the first argument is the address to the variable that we just declared, TID0. And it's going to come up with a new ID, and it's going to assign that new ID to this TID0 variable. So we pass in the address of that declared variable, and then in the second parameter to the pthread create function, the second parameter is a data structure of attributes that you can assign to the new thread that you're creating. And these attributes describe the behavior of that thread and how it's going to behave and what it can do and what it can't do. For instance, a thread can be made not joinable. So basically that means that its life cycle is not going to be dependent on the life cycle of the main program, of the thread running this main function. So it will have an independent life cycle. In this case, we're going to use null, so we're not going to pass in any attributes. We're just going to keep the default behavior when we create this thread. And then the third argument to the pthread create function is a pointer to the function that you want this new thread to execute. So when you create a new thread, you have to give it a piece of code that it can run and execute. And we do that by passing in a function. So we refer to a function that thread will then execute the code inside of that function. We haven't created this function yet, but I'm going to just name it here. It's going to be called worker thread func. And then in the fourth argument and the last argument that we're going to pass in is actually the input to this worker thread function. So if we have any arguments for this thread, we can actually pass them in this fourth parameter to the pthread create function, and it has to be passed in as a void pointer. Okay, so this is going to be, in our case, what we're going to do is we're going to pass in the thread ID into our worker thread function. So what we want this worker thread function to do is basically just print out to the console, hello world, this is thread, and then print the ID of that specific thread. So it should print this value. So now that we have this pthread create function set up, let's go ahead and call the pthread exit function, and we're going to pass in null as a parameter to pthread exit. So the pthread exit function basically forces this main thread to wait until the thread that we create in pthread create is finished with its work. So it will execute all of the code inside of worker thread function, and then this main thread will exit. But if we don't include this, what will happen is the main thread will exit too fast. It will exit before this worker thread function can complete its work, and so nothing will be printed out to the console. And I'll show what that actually looks like later on, but for now, we'll just keep this this invocation in the program. And the last thing that we want to do is we want to return 0, and that will actually exit the program. Now that we have our main function set up, let's go ahead and implement our worker thread function. It's going to have a void return type, and it will take as input a void pointer, which will be the thread ID. And we have to cast that thread ID to a long integer, so we're going to create a new variable, a long pointer, and we're going to set that to the thread ID argument. And now that we've done that, let's go ahead and print out to the console, hello world, this is thread, and then we're going to use a string formatter to insert the thread ID. Alrighty. So now this program, when it runs, and let me just add a new line here so it's a little bit more readable. When this program runs, it will create a new thread, and then that thread is going to take as input that thread's unique identifier, and it will print that out to the console. So let's go ahead and compile it and see if it runs. I'm just going to confirm that I'm in the right directory, and I am. So to compile the program, I'm just going to use gcc and then empty-example.c. And when we compile a program that's using the Pthreads library, we actually have to link it using the gcc option -l pthread. Okay, so it won't work if we don't link pthreads here. Okay, so it worked, but it did give me a warning. Let me fix that warning. It's just complaining about what kind of, let me just, forgot to dereference the ID. So let's recompile. And now that generated an executable file, a.out. So I'm going to call a.out here. And then it prints out to the console, hello world, this is thread. And then this is the unique identifier of the thread that we created. So that was simple enough to do, but let's make it a little bit more complex. Let's actually create several threads in our program. So we're going to modify this and convert this into a for loop, and we'll create 3 threads, and they'll all print to the console their unique identifiers. So the first thing that I have to do here is I have to declare 2 more thread ID variables. And then I'm going to write a for loop here. We'll do int I is equal to 0, I is less than 3, and then increment I. We'll place the pthread create function inside of here. Now, in order to provide each thread their respective thread ID variable, what we'll need to do is put the addresses of these variables into an array. So what I'll do is I'll create a pthread type pointer array, and it will be equal to the addresses of the thread IDs. All right. And then when we iterate over this for loop, what I'll do is I'll just simply refer to index I as the correct variable. Now when we run this program, recompile it and run it, what we should see is 3 print statements printed out of the console and then 3 unique thread IDs. So let's go ahead and recompile and see what we get. And so you can see here now each of these numbers is unique. So we created 3 threads, and each one of those threads printed out to the console their unique identifiers. So I mentioned that I would also show you what happens if we were to not call pthread exit. So let's go ahead and remove pthread exit and just see what happens and recompile here. So you can see the program immediately returns, and the reason for that is that the main thread that's running this main function here is immediately exiting after it completes this for loop. So as soon as it completes this for loop, it's returning, and then the program exits. And so it doesn't wait for these three p threads to complete their work and print to the console. So that's why we need the call to the pthread exit to ensure that the main program is going to wait for these threads to complete their work before it actually exits. So let's go ahead and just recompile and run. So this is a pretty basic introduction to multi-threading, and I hope you enjoyed it. And if you did, please consider throwing a like on the video and subscribing to the channel for upcoming multi-threaded videos. In the next video, we're going to kind of expand this program out a little bit more, and we'll get to see the behavior of threads when they're accessing shared data. So stay tuned, and thanks for watching.
Yeah, so these are the 2 videos on PT threads. So just to cut the long story short, as I mentioned, your midterm exam, it will be programming, no story writing and all, only programming on as I told you, the Ricard Agarwala and Maikawa's algorithm, which you will be doing. You can start working on it now. Likewise, for the end semester, the plan is to use only have a programming kind of assignment where we'll be using some threads, creating threads, destroying threads, and all those kind of things. So please start programming and trying out these kind of things. Already I have given the links. Now in the next class I'll be doing some videos on the on inter-process communication, IPC, which we already covered in operating systems. But I may be also asking you, using PT threads, show some sort of synchronization. How do you use a mutex lock? So I'm just giving you an idea on what the end semester exam will be. And in the end semester, I'd also ask some questions on election, bully algorithm, election, and maybe the the 3 Byzantine general and 4 Byzantine general. So these are the pretty much it's like a take home end semester and a take home mid semester or midterm. You're not going to have any other this thing anymore. As such, the classes will be suspended from next week. I'll mark all of you present. So please use the time for doing all these assignments and completing the job, so as to speak. So that's all from my side. I'll close for today. We'll meet on Thursday, and then on and off we will meet if required, and so on. But please start this work by the end of this month, perhaps the beginning of October. You will have your midterm exam. So you have to start now. You can't just do it in one day and all. You can't do that. Please do it on your own. I may also use some plagiarism detection thing. So you will have to do it individually. I'm going to use that software also for that. So please ensure that you don't copy. You just do it on your own. And it will be one of the assignment, one of the 2 programs, Maikawa or Ricard, which I will not tell you how I will decide. So that part will be decided later on the midterm day. But midterm and end term, the Viva will be based on the syllabus. The midterm will be only the distributed computing, completely, and a small fundamental part of the parallel computing. The first few, maybe the first few pages or the first 10 or 15 slides. So that will be your pointer. The first 10 or 15 slides of parallel systems and the entire distributed systems will be the syllabus for the midterm. For the end term, I will tell you, probably I'll tell you, I'll reduce the syllabus even for the end term. I'll tell you what to study for the Viva. I'll skip some part. Probably I will only plan for the parallel systems for the end semester. But see, all these are between you and me. Please do not tell others and create problems for me. Okay, Sherry. So that's all from now. We'll meet on Thursday. See you on Thursday. Bye. I think everybody is there. I'll mark you present. Okay, bye. Students, can you hear me?
Sir,
Yeah.
I have a doubt, sir.
Okay, bye.
Sir,
Yeah,
sir, I have a doubt, sir.
correct. Tell me.
Sir, for the midterm, we will only have to show how it works, no, sir, the algorithm with an
Yeah, what
exam.
I will be doing is you will be doing a submission in a very short amount of time.
Okay,
It will
sir.
not be 1 hour and all. I'll give you a
Okay.
question and you'll have to submit. Then I will connect to you individually and see how you have done it along
Okay,
with
sir.
the Viva. That's the plan.
So, like for the midterm, we don't need to do the wedding and all, no, sir.
Only
Just
these two you have to study. I have told you already. Maika was.
those two, like even you can do it with wedding and without wedding, but
No,
threads are not
threading
required.
only these two I am talking of the midterm exam, online
Okay, sir.
exam.
Okay, sir.
In the
Okay, sir.
midterm online exam, only these two algorithms will be asked.
Okay, sir.
Maikawa and Rikat Agarwala. And all of
Okay,
you
sir.
will get one of them, right? But you have
Okay,
to
sir.
do both. You can't, I can't tell you who is going to do, which part I have not decided. So
Yes, sir.
you do that for the midterm, you submit the assignment in a
Okay, sir.
whatever I will have to see how you submit the assignment. I will
Yes,
use
sir.
flag detection to check if you have copied, number one. The
Yes.
midterm Viva, on the other hand, will be based on the complete distributed computing syllabus, as also the first part of the parallel systems, the fundamentals of parallel systems, that first part alone. Now, end term, you will have again a programming assignment, a programming exam, which will consist of election algorithm, Bully algorithm, that consensus algorithm, 3 Byzantine generals, 4 Byzantine generals, and you will also have this PT threads assignment, means how to create or destroy PT threads. That is the plan for the end semester.
Okay, sir.
And the end semester Viva will be based on the only on the parallel systems. It will not be having anything on distributed. But this is the plan that I have. If the university policy comes that you have to do, I cannot do anything. I am trying to simplify things for you, but I am bound by some university policies, and you people tell it to others, and then I'll get into trouble. I believe not in cramming and stuffing. That's my style. Okay, is it fine? Are you clear now?
Yes, sir. Thank you, sir.
Okay, sure. I got all the submissions that some of you have given. I have marked it also. Okay, bye bye. See you.
Thank you, sir.